Now let's move on and think about how can we classify these materials.
Okay.
Now here is a table that gives us some summary of how these materials can be classified. We do have what we call metals and non-metals, and the two can be contrasted. Whilst we have our metals being shiny, and we call that property the metallic luster.
Okay, the
right?
shininess.
Yes.
Yes.
Shininess of metals. On the other side, non-metals are dull, so they're dull looking, they're not shiny, they don't catch your eye immediately, like metals would do.
And of course they're later on, and of course when you get into grade 11 and grade 12, you're going to be talking about why metals are shiny.
Yeah.
And yes, we'll show you why they're shiny. There's a very good physical reason to do with how metals interact with light that makes a metal shiny and a non-metal not shiny.
Yes, very important thing. Keep it in your mind, and as you move on to grade 11 and 12, you would need to come back to it and explain it in details. The next part, we know, or we have found out that metals are malleable, and that means we can hammer them into shapes, we can bend them into shapes, right? On the other side, non-metals are brittle. In other words, as you try to bend them, they break.
Okay, so malleable, or you try and shape them. So you can't take a piece of pottery and hammer it around a shape, because it'll just smash.
Yeah, it's not going to.
But you can take some copper. Okay, you can take a mixture of copper and tin called brass. You can shape that, but you can't shape a piece of wood. You can't hammer that into a shape. So metals are malleable, and that of course is one of the things that make them so valuable.
So special in a way. Right, and then the next thing that we will move to, it's the ductility of metals. Metals are ductile, and on the other side of the non-metals, we are still saying they are brittle, because when we say metals are ductile, we are saying they can be drawn or stretched into wires, but a piece of wood can't be stretched into such. And for that reason, we will still say that they cannot do that because they are brittle. Yeah.
You know, if you think about the effects of our materials on our history, look at something like barbed wire. Now, until you could make, barbed wire fenced off properties, and when you fenced off a property, that was your property and you were protecting it. Now, it was more difficult to do that with wooden fence posts. The other thing, of course, you have to cut down a lot of trees to make wooden fence posts.
Yes.
So now we make this, we use our technology, we draw out, not only do we draw out a piece of wire, but we can also put sharpened edges on it. And think how important the sharpness of a metal object has been in our history. Some of it not so nice, because some of it had to do with war and killing other people.
Yes,
but it's a property of metal that has had a great effect on our history.
That's true. And moving on, looking at this contrasting metals and non-metals, let's look at the last two, and we're talking here about their properties. When we look at metals, they are good thermal conductors. And by thermal conductors, what do we really mean? We're saying that metals can conduct heat. The word thermal has to do with heat, right? And on the other side, the non-metals are thermal insulators. In other words, they don't allow heat to travel through them. And lastly, these metals are good electrical conductors. In other words, the whole electricity that we receive in our homes,
or don't receive.
Yeah.
Yes, sometimes there's load shedding.
Sometimes we don't receive that. Yeah. Now, that electricity is actually transported into our houses, companies, offices, through metals. because they can conduct electricity.
All the wires that you see, the pylons, the Eskom pylons. But you know, the jokes aside, we talk about, I see there's some local person talking about joke shedding now, but there is something good that's coming out of this, the problems we're having with our electricity supply. It's telling us, don't take this for granted, because it's expensive.
Yes.
And secondly, it's perhaps teaching us that we must be a little bit better at conserving our energy.
Exactly.
Because it's not for nothing.
We should be thinking about saving all the time.
But that's a commercial. So I think we should get on with the show.
Right. And now, electrical, in terms of non-conductors, we've got, or non-metals, we have them as electrical insulators. In other words, if we don't want current to pass, we are going to make use of a non-metal to stop it.
To make it a resistance, which we've been talking about as well.
And we know once we do that, it won't pass, because this thing is resistant to the flow of charge.
So all of the things that we're talking about under matter and materials, or many of the things we've touched on already, but now we're making it explicit, which is really good.
Exactly.
We haven't shown many metals, have we?
We haven't.
But I want to show one.
There is a piece.
Think of the importance of that use of metals. And why do we use metals here? Well, some metals are very resistant to corrosion, another property. Some of them are not. Iron rusts. But so that's why we don't make many iron coins these days, because they last much longer when they are resistant to corrosion from, let's say, acid or from weather. We can heat them up without changing their form. And so metals in coinage are very important use of metals.
Exactly. Thank you for bringing that in. It's a good use
It'll cost you.
Yeah. Thanks, Peter.